Hello everyone. So today we are gonna take a question, merge case sorted list. So this one is answered. Let's say, okay, let's write the title, merge case sorted list. I guess sorted list. It's taking time to load. Okay, merge case sorted list. It's the 23rd question and it is hard question. Okay, let's read it. You are given k linked list. Okay, we have k linked list. First one is this. Second one is this. Okay. Okay, let's take an example directly. So 1, 4, and 5, and it is given as list of list node. Then next is 1, 3, and 4, and 2 and 6. As we can see, all are sorted. Further, what we have to do is we have to merge all linked list into one. Okay, we have to merge it. So to merge it, what we can see, and sorted in ascending order. Okay, okay. So to merge all of them, if there were two only, then we could easily merge it. But to merge all of these, more than one of them, we always need to find the minimum of it. Okay. So let's see. If we have to do in order of some n space, okay, what we will do, we will take all of them, put it in inside array, then sort, okay, then sort it, okay, not out of n, out of log n log n. Let me erase it. Yeah. So to do it in order of n log n, it's quite simple. Take it into array, then sort it. But to try it in order of n, okay, let's try to do it in order of n, and if possible, then order of 1 space complexity, extra space complexity. Okay, okay. Mm, but we have to find min from here. The other way is without creating in order of one space, what we can do, we can merge both of these, okay, then for others we will merge them, then we can merge them, okay, then this will be in order of n log n again. I don't think so that we can achieve order of n through this, and list length is also 500, okay, each of them is 500, so yeah. Okay, let's try. Other way to do it is in array of n is here, like, see, the best part of all of it is the list of i's is from -10 to the power 4 to 10 to the power 4. So if we take an array, okay, and keep the count of all the integer appeared, then we can solve it in order of n. Yeah, order of n, not order of 10 to the power 4. Okay, we can also do that. Now what else? So before all of this, let's try this option. Merge two of them, then merge it again. Okay. Can we do in recursive fashion? Uh, so if we are giving input a whole list, okay, divide it into merge this, and then merge both of them. Yeah, this is kind of merge sort instead. Merge sort. We can use the merge sort here on a list of list of linked list. Okay, let's try to write some pseudo arrow here. Hmm, so let's suppose we have our function list of linked list. Okay, So we will take our mid. Okay, not like this. List of linked list. Left is there, right is there, and then mid is equal to L plus R upon 2. Okay. Now merge the left to mid part. Okay, and merge mid to right, not mid to right, mid plus 1 to right. Okay, now what? After merging mid and then mid plus 1 to right, the next thing we could do is merge. We can store it inside some array, like the left is, okay, left and right, and then finally we can merge left and right, left comma right, and return them. Okay, and return it. So okay, so each of them will be gonna merge. It will be in order of n log n. Worst complexity could go order of n square, but yeah, no, not worst complexity, is merge sort now. So we will have our order of n log n. Well, let's try to implement it. So much talk, let's go. We can go for discussion also. Let's see what they are saying. One second. Solution. Okay, brute force. Okay, yeah, brute force is itself order of n log n. Compare one by one. Kn. Post 3 is optimize approach to by priority queue. Okay, yeah, like merge list one by one. Kn. Merge with divide. Yeah, this is what we thought. Okay, this is directly approach 5. We have to, in the interview you should start from the first one and go to the end. Let's try to, okay, we already have our approach 5, so we already thought of it by ourselves. So let's try to implement our own approach, which is fifth one. Okay, so okay, let's take merge sort. We are gonna make a function merge sort. We are gonna pass the lists. Okay, let's convert the name into array, it will be better. Okay, we have array of linked list, arrays, array of linked lists. Cool. Now what we can do, merge sort, and we will give L and R. Okay, should we give it? Yeah, let's give it. So L is equal to initially 0 and R is equal to length of array. Okay, length of array minus 1. And after that we are gonna sort left and right. So to find the left and right we have to divide it L plus R upon 2. But before dividing it, okay, no, we will take care of base cases after that. So this is our mid. Okay, now dividing into two parts, so let's say the first one is left. Okay, left array of mid, not mid, initial to mid plus 1. Okay, we are gonna pass this array to merge sort. So we are going to sort the left part, and L and mid will be given to it. Okay, cool. And same we will do for right part of the array. See, array of, from, it will be from mid to end. Okay, yeah, now what? Yeah, mid is taken, so mid plus 1 should be taken here. Okay, let's hope we won't get any error. If we will, then we are gonna debug it. And here left is mid plus 1 and right is r. And finally, we are gonna return the merge by merging left and right. Okay, let's see how it could work. Now, we have one more thing. So if L is equal to R, if L is less than R, then return if L is equal to R. Hmm. If this will happen, then we are gonna return our current array L. Okay. Yeah, this should work. Or else merge it and then, or else divide, sort, and then return. Yeah. Now we have to write only our merge function. So let's write our merge. So this is dividing into two parts, and then here it is merging. Cool. Now these are what we can say of base cases. Base cases. Now let's define the merge. So we have left and right. Okay. We have left and right. It's already 11 minutes. Left and right. Now we have to merge it. Yeah. So yeah, okay. So like recursion works like magic now. If we are gonna call these things, it will always return a single linked list in left and right. So all we have to do is merge and return. So while left and while left and right. Okay, let's create a new linked list. That's gonna take another space, but still we can use it. So it will be our temporary, or rather merged. Yeah, merge will be better option. Merged list node. Okay. Yeah, so what we can say, let's create a linked list node of minus 10 to power 5. Okay. So if left dot val is greater than right dot val, then merged merged dot next is equal to, yes, somehow we can also replace it, like instead of using merged we can convert left and right also, but for now let's do it simply without any problem. Okay. Copy, then right, do it right dot well, and then further, yeah, right dot well, else left dot well. Yeah, so left dot well, and so what I'm doing here is, uh, if I'm just merging the two linked list. So how could one merge the two linked list? It is same as merge sort in array. If you have studied, like we have two arrays and they both are like 1 2 3 and 1 2 4 and 3 5 6. So we will take the minimum of it, then if it is minimum, increase the pointer goes here. Okay, initially pointer was here, now pointer is here, its pointer is here. Okay, current pointer is here. Now the minimum of these two is 2, so 2 is here. Move the pointer to 4. Now this time 3 is minimum. Okay, break it, pointer to next, and we have to do rest, the same in the rest of the loop. Okay, so yeah, I've done the same. Merge dot next is equal to list node of list left dot val and at the end of it, merge is equal to merge dot next. Okay, cool. And let's keep track of merged also, like temp is equal to merged. Now further here, if we are putting right value, then right is equal to right dot next. Same with left is equal to left dot next. It is simple, like you don't have to, it is simple, it is like a left plus equal to 1 when we do merge sort. Okay, next. Now for the remaining part, yeah, if left, then merge dot next is equal to left. If right, then merge dot next is equal to right, and return temp dot next. Okay, cool. Yeah, now it should work fine. Let's call our merge sort and see what's happening. Return merge sort. Okay, merge sort on array. Left and okay, everything is given already here. Let's see. Okay, output is an empty. We are merging it and returning it. Return temp dot next. Okay. Let's see where it went wrong. Oh, if L is less than R, not if L is greater than R. Base case was wrong. List index out of range. Okay, okay, I see. So L is going negative or what? So L to mid and mid plus 1 to R. This could be the problem. So instead of using mid plus 1, let's use mid. Okay, mid minus 1. Yeah, let's use no. Hmm. So L plus R upon 2. Okay, let's dry run our code on this example. Okay, we will get better analyze. We will do better analysis through that. We can do better analysis through that. Okay, let's see. Yeah. So we have 1, 1, 1, 4, and 5. Sorry, 1, 4, and 5. The next one is 1, 3, and 4. The next is 2, 6. Okay. Now what we have to do is we are our L is 0 and R is what is R? Length of array minus 1 is 2. Okay. Not 2. It should be 1. Okay, no. So the mid first mid will be 0 plus 2 upon 2 is equal to 1. Okay, this is our mid. At first what we are doing is we are passing this to first function. Okay, and for the next one, mid plus 1 to last. Okay, mid plus 1 to last. And now for this, L is 0 again, and mid is now 0. No, mid passed in here. Okay. So if length is 2, we can merge it also. What if length is 2? Hmm. Yeah, we are merging left and right and returning that node now. Okay, let's print our ln. That will make sense. Print ln r. Let's see whether it will make sense or not. Okay, 0 2, cool. 0 1, and then 0 0, then 1 1. And okay, so the past array. Okay, so we have to print one more thing, L comma R, and then array. This will give us understanding what the current array is it is working on. Okay. 0 2, and then array is 1 4 5 1 3 4 and 2 6. Cool. Then 1 4 5 1 3 4 0 1. Here 1 4 5. Okay, that could be the reason. Yeah. Instead of trimming the array, I should have rather passed the array diagonal. Second, PC is hanging again. Cancel. Also, instead of see, when I pass this, I already sliced the array. This is the real problem. The sliced array. Okay, instead of slicing array, I should have passed the array itself. Now I'm passing the array itself. Yeah. Now let's see what's the output. Yeah, it is accepted. Okay, for this one, but let's see the constants too. Like k can be 0. So if k is 0, then return. Yeah. So if length of array is equal to 0, then return. Okay. No, if length of rather we can do it like this. If length of array is less than equal to 1, then return array itself. This will work for single array. Okay. Let's try on empty linked list. Input is this. Okay, we have to return a linked list or list node now. That's why. Okay. So instead of returning array, we have to do this like if length of array is equal to 0, then return, then directly return, and if length of array is equal to 1, then return array 0. Yeah, let's yes, let's check this whether this is working or not. This is working. The third test case is this. Okay, all test case passed. Let's submit it. Okay, it's taking time. Output limit. Oh, I guess I'm printing something. Yeah, I'm printing something. That's why output. Okay. 1 second. Return. I'm printing LR. Yeah, I was printing LR with this. let's comment it out. And now some. Oh, submitted. Thank you guys. Subscribe for more questions. We'll meet soon. Thank you.